And I have a Lindsay's as my first. Okay, so I remember Lindsay being online today. Give me 1 second. I'll leave room and check. Okay. Is this the right one? This is probably still in this. Yes. And this one should be. For some reason, it's pretty slow. Should be this one. Okay, give it 1 second here. That one. Huh. What? That's weird. Showing up. All right, cool. Finally, thank you for your patience. So you have a solution for a W pattern on the parking lot. Question is about how many DIs will I need for the W pattern? How should the contours run of buildings? So you have the general direction of the contours are correct. And do my LPS may, so your LPS, no, not until you start connecting those contours, you won't be able to know if your LPS makes sense. LPS, you can first kind of, let's try it here. But then once you start connecting those contours, you find out, okay, I still have to move my contours in this area, then my LPS could not be there, right? And frankly, you don't really need swells on either side. You can actually get away with not having a swell, but that is, again, case by case. It needs to be dependent on the grading of your FFPs and the areas in front of your building. So we don't really know yet if your LPS makes sense. About the BIs in the parking lot, you know that, yes, your swell is the darker, the thicker black lines. So you want to make sure that at the end of, or when you are making some transitions, for instance, we are transitioning from the parking lot to the driveway. And those locations would be where you would need water to drain so that you don't have ponding areas where critical connections happen, right? So at least along this side, water is draining this way, that way, this way, that way. You would at least have these. As long as you have these 4, you won't have anything deducted. If you want to make sure, okay, let's just make sure absolutely there's no ponding water, then I can add more, which can be integrated with the island design. And here you want to avoid the ADA access. You want to say before the ADA ramp, I have a DI so that I don't have water draining kind of through that area. So that's where you can put it. And here the same thing, if you want to add more kind of security to avoid ponding water, you can add them there. Now, you kind of have to look at this. this is, you're creating a swale here by doing this pattern, flipping the pattern, right? So you would have water draining like that in your turnaround. So basically the DIs would be here around the turnaround. So those are the DIs that you would need if you are choosing that W pattern. If you're not, then it's actually in the corner there, but we won't go there to confuse you. If you want to take care of this area as well, you can put 2 DIs in that area too. But again, that area we are not grading very strictly in that area. Okay, but yes, you would need 1, 2, 3, 4, 5, 6, 7, 8 at least. Okay, so I'm gonna erase the one that it's not necessary or it's optional. So this one, in the middle, you can get rid of them. But these 8, are the correct ones that are necessary. And we're grading loose in this area, so that area we won't deduct points, but it's correct to include those 2. Okay. So, questions? It is the same. Yes, you do the same formula, but the only thing that you change is if it's integrated with a curve. No, so you can put it in the middle without having any relationship with a curve, right? In that case, you would just say DI. If it's integrated with a curve, or kind of it's on the actually the bottom of the curve is the DI, then you would say DI/TC. But the DI spot elevation is exactly the same as your BC. Okay, there's no special calculation necessary. You just based on the parking lot spot, but change the label to DI, DI/TC. Yes, yeah, DI is the BC, and you can TC/BC or no, TC/DI or DI/TC. You just need to make it consistent about labeling all the curve spots, right? Or TC/DI. Replace, yes, yeah, replace the BC with DI. Then consistently make, yeah, do it that way would be okay. Okay, so I'm glad to see, Robert, I'm glad to see your front contours, because they are roughly in the right direction, because you have water draining that way and that way. And you have something needs to turn, but this area, it's not, you don't need to turn the contour here. But if you have a contour hitting this curve, then you would need it to turn like that. Okay, yeah, so that's that little change here, you would do something like this. You would want to turn it once it hit the wall, okay? But the general direction is correct. And I would say it is roughly correct until you get to this point. Let me zoom into a certain area so that you know exactly what I'm trying to. Okay, here. I want to talk about this one. So it is correct up to this point. If my sidewalk is designed with a 2% side slope as your parking lot, we know that your parking lot along, along this way, or by having a contour in this direction, or having a contour spacing the same as your parking lot, it means this area is actually at the same slope as your parking lot. Does that make sense? It is only like, it is only half foot above, but you designed based on these two contours, you designed this area exactly the same slope as your parking lot. But then in fact, when you look at your walkway, it is sloping that way at a 3% slope. So the slope doesn't match, which means it is still this direction, but it needs to turn. Okay, how exactly does it turn? You have to calculate now. How do you calculate? You calculate that spot and this spot, and you find out where exactly 71 is on the sidewalk, on the walkway, and then you turn this based on that. You can even extend it over, and well, it actually still depends on how you where that 71 it's located on the sidewalk, and then you connect them. Okay, so it will turn in some fashion, and then it hits your porch. Okay, so the direction is the same, but the slope and the turning, kind of the folding of the contour line, needs to agree with the calculation of your walkway. Go ahead. Mm-hmm. That's the middle of the parking lot. Yes. Mm-hmm. Yeah, if you want to draw, you can get on Zoom and you can annotate. Okay, but as far as I understand, the W we created by mirroring it kind of over that the thicker swell line. That means direction changes, but the slope was still around 2%. But the area in front of your building here, now you have a 5% and you have a 3%, meaning that your contour spacing changes. It is not following the original contour direction anymore. So how exactly should you connect these contours to the porch area? It's dependent on the spots now. It's not, you have to calculate some of the spots, especially these ones. Oh, these ones are the ones that are fixed because you determined this is 3%. And these ones are the ones that you determined by a 5% slope. So these 4 and those 4 cannot disagree with your contour. All right. And once you have those calculated, you can determine, because this portion of the contour is in a green area. Okay. So it means you have some flexibility in terms of how it turns. But for instance, if you calculated this to be 71.01, that means your 71 contour is actually very close to 71.01 here, which I think is a mistake. I think there are some errors that happened that led to this being 71.01. Because if I look at this one, that's 71, meaning this is higher than 71, meaning the top of the curve is even higher than 71. I think you went down instead of went up. So you need to go up and recalculate that one. So for instance, if you calculated this one for it to be 72.01, that means your 72 is around this area, but those 72.1, for instance, needs to be on the higher side of the 72 contour. That is what I mean by they cannot conflict with each other. Okay, go ahead. Yeah, so the purple remains because you designed, yes, right. Yes, that's right. Okay, so that is that. Okay, let me very quickly look through if you have your walkouts and ADA access figured out. So that direction is correct. This is correct. Those are there. Those should be flipped. So that means 70.5. So there is a chance. There is a chance that these are actually calculated correctly, but I would double check. So it means there's no walkout here. And so far I don't see any stairs. Thus this one needs to be recalculated. And I think this should be, so 71 here, 72, and I think this should be above 72, meaning this should be walkout. You should be able to have a walkout here. And then this one, you have, again, 71.5, for instance, 72, 72. This looks like it's likely calculated correctly. 63. Yeah, that one, you should be able to have a walkout. So you have 2 walkouts. So walkout should be solved. That one is 70.65, TC 71, 70. This appeared to me a little low, so double check that one, a little low, but should not be off too much. And yeah, this could be, it's likely hard. Well, this should be okay for walkout again. There is a possibility possible. Now you probably need to determine on, yeah, you don't actually have to have stairs in this case. It's possible that no need for steps. Okay, so that's that. They're not required. Yeah, they're not required. You don't have to have stairs, as far as I remember. Might be required. Okay. Well, it's always safer to check. Okay, let me double check. If I misspoke, scratch that. Okay, let's make sure. Okay, so let's put in a set of steps regardless. Okay. Sorry for misspoke about that. Okay. How should the contours in that solved? Well, let's check one set of the bottom just to make sure. Okay, so you have 363, that's good. That's 2% good, okay. This one is 62. Okay, so we have a problem here. Let me try to show you about something about the wall. So you have this as 60.76. And then here, the bottom of wall equals to 63.27, meaning that you're actually going down. Does that make sense? So that means you'd have to have a wall longer to go over that difference. So that BW here would not conflict with 62.76 here. Basically, you have a lower ground on the west side and a higher ground on the east side, and that wall has to get both sides to a common elevation to connect to the ground. Okay, so that means you could have a flatter area here, but your wall needs to be extended. Your wall needs to be extended to somewhere so that this elevation, based on this two minimum slope calculation, but that one works for this area as well, which actually just means that you'll have a steeper slope once you get off your patio. This slope will be steeper to get you to a common elevation here based on the calculation of 62.76 sloping away at 2%. Does that make sense? Okay, good. So that's how you correct the wall over here. So you would have a 62 contour hitting the wall somewhere here. It might be a little bit away from that, meaning that your wall will be actually standing longer to cover the 62. Yes, you'd have to. Okay, so you'd have to have a 62 extending over, then your 62 can continue on the other side. Well, let me take that back. If you have a 62 over here, you'd have to have another 63 somewhere over here. That's your 62. That's your 63. And the wall needs to be in between. Then your 62 can continue to go connecting to 534. Okay, so that one can go here and connecting to the 62 contour. That is how your 3 and 2 can go in this scenario. Okay. That is 62. So 62 actually needs to be up there unless you have a wall. Unless you have a wall that's going that long. Okay, let's not do that. That is very long. If you do not need an extra walkout, actually you can have the spots here higher than your BFFE. Does that make sense? I don't know if you have all seen the cross section that I used to draw. It's like what Stuart just had. You have a top FFE over here. Parking lot it's on the side. And if you have a walkout, that's your BFFE. If you have a walkout, that actually means your ground slopes away like that out of your back patio. If you don't have a walkout, you could have this situation where you only, in this case, you only have a window here for your basement. So there are the soil, a field is on the back, then you cannot walk out, but you are likely able to get a window of some sort for your basement, right? Which means this corner elevation, which is here, that elevation can be higher than your BFFE by a lot, but lower than your top FFE. It needs to be lower than your top FFE, but it will be a lot higher than your BFFE. So in that case, you do not have to have you do not have to have a 72 contour going like this, right? You can actually have 74, for instance, hitting the wall like that. Your 74 can be like this and hitting the wall, and this being 64 points. Okay. All right. Good question. Can be higher than the bottom FFE, and yes. Yes. So the general rule of thumb is actually looking at the surrounding contours. The surrounding contours is like 6513, right? If this is 64, then it's very easy to connect back to original contour. So use the surrounding original contour to guide how much the corner can be. Again, that is flexible and can be estimated, does not need to be calculated. Okay. Yeah. Those, if you don't have a walkout, you can leave the corner later once you have your contours, because it needs to be based on the proposed contours. Go ahead. If you have already have two, the other ones you don't have to have them. If it makes it easier to go connect back to existing contours, then you can specify them as no walkout. But if you, or it's a design decision, right? If you want them to all to have walkout, it's still doable, then you can go out of a way to connect to existing contours to create the walkout. So it is a design decision, but the requirement is to walkout, no need to have more, can choose to have more. Okay. All right. So wow, am I muted just now or for a long time? I don't know what I clicked. I'm sorry. Okay. How do I create the patio? How do you know? I think it's at least 100 square feet, right? It doesn't have to be exactly 100 square feet. So you can make it larger. Yeah, the patio does indeed affect the proposed contours. How do I add stairs? Stairs would be in front of your building. So let's take a look at the parking lot questions first. So for the outside of the drive, I may need you to clarify that. Oh my gosh. Folks, I'm so sorry. Okay. How do I find the TC? Do you mean for this area in particular? Okay. So that one will be determined on this. So you extend this line. Well, for this one, we're not requiring you to do the transition. Okay, this year we're not requiring you to do the transition. So you actually needed to find out what you need to mark is the one that I have purple lines on. Those are the tangents. Because you have a 68 here, you actually don't have more contours in this area. I mean, integer number contours here, so you don't necessarily need to calculate that one to be able to draw contours in this area. That's what I mean. So I'm going to show the method of calculating it, but again, we're not requiring it for this year. Okay. Yeah, those two are what you're supposed to grade. What you're supposed to include. The one extended, yeah, that one is for you to calculate the contours in this area. But no, I say at this point, don't worry about this area. We're not requiring it for this year. Okay, so if you want to know how to calculate this, you would calculate the slope based on the spacing here. Then you would know what the high point of the road would be. Okay, once you have you have the slope of the road overall, you measure the distance between these spots with your this contour, basically the spot, and use that slope, use these two slopes to calculate the spots that I circled. It's basically calculating two slopes. They're very similar, but they're not exactly the same, but you can treat them similar. Okay, that slope, and use the slope and the distances, that distance and this distance, to calculate the spots along that curve. Yeah, so that's how you calculate those two spots. For the draining inlets, we just explained. For the spot elevations here, one thing that students really not kind of overlook is actually the quotes. So these are the quotes, I would say, the quotes. And then any tangent points. I remember there are, for instance, 4. Yes, exactly as you marked. There are 4 on each side. So that means there are 8 here and 8 over here. So is in total, you would have 16 spots. You have the slope here, and the slope will be flipped on the other side. So actually, this one, yes, that one would be the same as that one because you're going down and going up, right? Yes. And then for that one, you actually would base that on if I am flipped. Yeah, this is a little difficult. You're flipping this. So in fact, the slope keeps going is this slope. Use that slope to calculate this one. Let me make that. So what's being the same? What's being consistent is the slope that I just drew. That slope will keep going in this surface, in that surface. Does that make sense? It's not along the center line. Yeah, it is the cross slope. That is, you measure that and that, and you calculate this. Okay, so use that slope. Use that slope and this distance that I just drew. This is 69. Yeah, and that distance and the slope here will determine the spot elevation at the quilt here. Okay. Yeah, this is your contour. This is your contour. The red lines are the contour because you are going down and then go up. So use a line that's perpendicular to your center line. Yeah, it actually needs to be perpendicular like that. Use this as your mirror line and flip these two lines, and that's your 69 contours again. So those two are your only contours. They form a closed contour with inside the roundabout. That's your 69. Yeah, and then your 70 actually goes out of the outside. Your 70 is actually here somewhere, connecting back to here. Okay, yeah. All right, so that is about the roundabout. Okay. So let's do a quick check of the FFEs again, 70, 74, 33, and if this is an ADA ramp, no, 70.9, 71, 62.39, 62. That is your 62. So there's a chance, okay. It's likely that you can't have walkout over here, no walkout. And this one is supposed, I will need to see if that one is calculated correctly, 71.17. Yes, yeah. I can tell that this is not mirrored. This is flatter on the other side. Yes, it is flatter on the other side, which is not wrong, which can work too. It's okay. You don't have to mirror it because we only specified that the crown be 3 inches, and you fulfill that requirement, and then you change the direction, which makes it still not over 5% of slope. So you don't have to change that. No, you don't have to mirror it to make it entirely the same. Okay. No, you would still need the same amount. Yes, the same amount of DI, and it will be along that swell line at the end of the swell line there. Yeah, it's the same principle. You only changed slightly the slope, so it's okay. Yeah. You do need to label that though. Yeah. Yes, you measure this distance to figure out the slope. Yeah. The slope of this surface. So that surface and this surface would be at two different slope because of the direction change. You just need to measure this arrow and figure out the slope there. So not really, depend on how you calculate it. If you draw a line like this, perpendicular or parallel to your contour, and draw another line parallel to the other contour, you would base your calculation. So this one will be the same as that one. Then you don't have to change. Then still your calculations are correct. Does that make sense? So regardless, along this line, along that line, it's the same slope. It is just that this slope is not the same. Sure.
And then I just added that. So I measured the distance between the contour and the path.
Then that's not correct because the slope perpendicular to the contour is not 2%. The 2% is along the center line. Yeah, so if you calculate it based on this, then that's not 2%. Yeah, this one is not 2%. That is 2%. Okay, so let me start over. Yeah, I'm trying to find out the easiest way for you to calculate. The easiest way is actually to project, because your center line is 2%, the perpendicular is not 2% yet anyway. So I still would think that you would be calculating the slope. That would be actually the easiest way. Extend this, measure that, calculate the slope, and then project your spot to the nearest contour. I still think that will be the easiest way to calculate it. So you calculate the spot based on the distance to the next contour. So if you want to calculate this one, I figure out the distance there, and I know the slope based on previous calculation. And then I know this is about 70.43. It's not that off. It's not off that much. Yeah. Right. So that's, I still would think that's the easiest way to calculate this, because you have a W. If you do the parallel approach, you will have a lot of projection lines and it might confuse. Yeah. Okay. So based on this one, that will have a walkout, and this one should be also, oopsies. And that one don't necessarily have to. Okay, I think you have all your walkouts that you need. You do need to determine whether or not what or where you place your ADA ramp. Okay, so this one is a little too steep.
Like it's like up to me, I guess.
It is up to you. It feels like you can use one here if you want. If you have that, no, I would lower it down to 2% and then see, in order to get to my current 74.56, how many stairs that I need to have. Yes, right. Yeah, if it's about 1.5 feet that you need to overcome, then you add 3 steps, right? Yeah, that's a straightforward way to do this. Okay. How do you create the patio? If you have the back patio, those 2 spots would be the same as your BFFE. Okay, those 2 spots will be your BFFE. And you can create a patio that's sloping away at a 2%. Then your patio is basically this shape. However, the size of it is determined by you. All right. And those 2 spots will be based on the 2% calculation away from your BFFE. All right. And your next contour here would be 63. So your 63 would be about where the existing contour were. No, you don't even have to change it in this case. You know, you might keep the 63 in its original location. It totally could work. 63 could be right there at the existing location. You don't have to change it. Does that make sense? Yeah. Yes. You kind of have to start on the other side. It's easy. It's a back and forth. It's definitely a back and forth process, right? So you would have contours in some ways like this, and that one would needs to go attached like this, and then you would start to see. Okay, so I will have to look at the above. Let me take a look. This one is easier if I start over. 71 would go somewhere like this. No, might not be. And then 70 would go something like that. And 69 should go something like this. And it does need to hit here. So your 68 is over here. So you can very quickly actually attach to these walls. You won't have a swell in that case. You don't need to have a swell in this case. Because you know, by choosing the W, you're actually able to raise your how to shush it. You wouldn't need to get rid of too much of the existing a little bit of a high area. So it becomes quite easy, no need to create a swell to try to drain water away in that area. If you don't, you actually, for this exercise, you can choose to have swells, but you don't have to have swells. It's not, for the solution, it's not required, but for training purposes, let's again, go back and check. swale. Yeah, it did not say, it did not say you have to have a swale. So you don't actually have to have a swale for solving the problem here. Would some students have a swale? Potentially, yeah. You kind of have to work on drafting up that contour, then you would know. So you would have 71 over here, likely going like that. Not necessarily. I'm basically drafting some things up. And the 70 would probably go like this. And you would have 69, that's 68, I believe. 69 has to kind of go around like that. 69 close, that's one of the 69. You have 69 over on the other side. So you definitely still have a 69. Yep. And then you might need a small swell on the side. I can't remember where 69 is. Over here. That's 68. So let's see. I don't know which one is 69, 68. Do you label? Did you label that one? Okay. Yeah. 5, 6, 7, 8. This is 9. Okay. That's 7, right? Okay. If this is 7, this is 7. That's 9. Oh no, this is 7 again. Okay. In that case, you have 7, 8, 9. 8 needs to, 8 still needs to hit the wall here. 8, that's 70. 70 needs to hit the wall, going up. And then 9 needs to go around and come over. And 8, it's probably a closed one, and then still needs to come around and hit the wall. And 7, well, 68, if you close it now, it can go around and hit the wall like this and then come back. Oh, that does not look good. So let's do this. It could go like this. If you don't have, okay, if you do not intend to create a walkout for this unit, you do not need a swell. Okay, if you intend to create a wall with a walkout, you likely need a swell in that area. Okay, so it really depends on whether or not you should how you should model or change the 7 over here to see whether or not this is actually forming a swell pattern. But it's not. I don't think you know, if you don't need a walkout, you would need a swell here. That's likely not the case. Okay, so that is that. Well, the contours over here is really dependent on your walkout. I kind of showed you how your patio could look like, but it's really dependent on how you design your walls and how you design your patio slopes, those things. And I definitely would encourage you to quickly work on a draft to make sure you understand the concept. You know, today's Thursday, we're still able to answer questions until tomorrow at 5 p.m. You could shoot us an email, which we'll try to get back to you. But Without trying, it's hard. Without a draft, it's hard for me to demo. Yes, yeah. It's not, it was only just an illustration. It was just an example. It wasn't not based on the length of the wall on the base map, but not based on a calculation of 100 square feet. Yeah, so feel free to extend it if you need to, or if you want to create a larger patio. Okay, so those are just for showing examples of what wall should be, how a wall should be represented. Okay, yeah, try to work on it and try to get a round of feedback on that one. All right, and it's better if we move forward because I don't know if I have enough time. Kristen, let me see if you're online. You are not. You're in the room? No? Okay. And Lindsay, just so you know, I did call you at the beginning, and let's go through the list and then I'll come back to your critique, okay? And then my next student is, give me the list. Claire. Oh, sorry, I probably mispronounced it. Okay. Okay. Okay, if you can share screen. Yes, yeah. Yes, you should be able to join. Just okay. Let me go back to the main room and I'll sign you. So yeah, you can ask directly your questions here.
Okay, so
Mm-hmm. The tick marks, right? Okay. So how walk me through the process of your process of calculating those spots. Mm-hmm. Okay. 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 So first thing, 39 would be the first distance of your tick marks. 50 will be the next one, right? So that actually raises the question of all the BC and TCs. Yeah, they seem to me a little low. Yeah, so start with the contours first. Now, if you can zoom into these areas. Okay, so let me show you very quickly how you can rectify some of the calculating issues. I know that you had 39 here, which is correct, okay? And then you should measure 50. So suppose that's where 50 is. That's your tick mark. And we'll do, project that one to the driving aisle. And I'll divide this line into 4. And this is your contour. If you don't want to flip and then mirror it, those are your contours. Okay. And once you have your contours, you can basically calculate that distance, whichever spot that you are calculating, whichever spot that you are calculating, project a line to the nearest contour. But at first, you do need to calculate the slope, the cross slope, by doing kind of the process that I just explained to others, measuring that distance, figuring out the slope here. And then if you know those distances, these distances to the nearest contour, you would know those spots. Okay, so, right. So that's the first thing, but I would not calculate the parking lot spots just yet. Okay, I will work on the parking lot contours first. And then once I have my parking lot contours, I would start working on these spots. In your case, I would probably use the middle because you design a very wide walkway, which is likely not necessary. Okay, because it's very wide and you could limit it to something like this, but use the middle of the sidewalk, that TC or BC, as a guidance of how your TFFE and BFFE needs to be. All right, so let me clear this and you can scroll down so that I can see your BFFE and TFFE. You kind of need to know the BC or TC here to know how high you can get to the FFE, right? I think that's probably what you did. Not able to clear. Interesting. Oh, that's a first time. Okay. Now we got rid of all the markings. So let's check. You have a BC equal to 70.36, and this is pretty low. So the first thing, let's suppose that we have walkout here, because we by reviewing submissions, we know these two are the easiest to create walkouts, right? So it's kind of dependent on which one we choose to have a stair or a ramp. If we say, okay, this one is ramp and ramp, then we know we will start from BC because there's no curb. We're not stepping up a curve to get to these two units. Now we have the BC equal to 71.10, and suppose that this is the correct calculation, okay? But we still have to go back and check. If this is the correct calculation of BC equals to 71.10, you actually use 3% and get to 71.53, use that as a TFFE, and that's the correct process. You did that part correctly, but realize that later on your sidewalk or walkway would be kind of narrower, meaning that this spot will probably be a little lower than that one, which is okay. It's not too low. Well, it's still based. It needs to be dependent on your recalculation. Use that number, new calculated number, to get to the TFFE here, and BFFE equals to 62.53, and then use that 62.53 and see if you killed the tree. My sense is that it's okay for this one to get down to 62. Let's scroll down just to make sure. Can you scroll down? That's 5, 4, 3, 2. Yeah, so that seems like it will be okay for you to have a 62.53, still have a walkout. So that one, I think likely the set of elevation that you defined would not change much, will still work. Okay. Let me clear. This house FFE is okay if you go back. Okay, let's scroll back and do a quick estimation to see if you're, so if this is 72 and that is about 71.5, I think you should still be okay. Based on my quick estimation, I think you should still be okay. Oh. Yes. Yeah. Okay. So again, let's zoom into this area. Don't know why my clear doesn't work on your machine, but let's use eraser. So if your patio elevation here is 62.53, meaning that going off 25 or 26.5 feet, around 25 feet, you are getting down to 62 contour. Does that make sense? So your 62 contour will be over here. And your 61 original contour is where the tree is. That is where the tree is. As long as this distance is not far farther than 50 feet, you'll still be able to keep the land draining without moving the 61. And that's why we know it works. Yes. Exact. Not less than 2% until the next contour. Yes. And this actually also means, well, it depends on how you grade this one. It's likely that you'll need to extend that wall. Depend on, again, that needs to be dependent on how you design this area. But well, how can I say? It's hard to explain why you will likely need a 62, because it's likely that you'll stack up contours in this area and when you get to this point, you are not 62 yet. But no, yeah, that's just, again, my experience tells me that you'll likely need a wall there. Okay. Okay. Okay, so if you ever need a swell, it will be HPS somewhere here and goes down like this. You would not need the swell to go around. Definitely not, because the land is sloping this way from the very beginning. Yes, the only drainage challenge you're facing is actually getting the water away from the wall, from the west wall. That's the challenge. It's the same thing. If you ever need a swell here, your HPS will be starting like this, and it's just trying to get water away from this. Yes, it's just trying to get water away from that wall. All this is already sloping in this direction, so you would not need anything that's going to wrap around the building at all. Okay, and as explained in previous reviews, for many of your solutions, you don't really need the swells. So I would not start with the swell. I would start with your parking lot contours And I would start with the contours in the front, something like this, and then I'll see how things, what's that contour and how does that work with the 68, and then I will decide on, okay, if I need a swell of this sort to direct water away so that I can create a walkout somewhere here, and this one very likely you would just do this and do not need the swell. That's my sense. Yes, yeah, I wouldn't, I don't think, I think most of you would not need a swell on this side. That one is still possible that you can use a swell. Okay. No, it doesn't hurt. It doesn't hurt. Yes, yeah, it doesn't hurt. Again, drainage problem is the most significant issue, and it's a big category. I believe it's at least 15 points for just that category. If you have water running onto your wall, into your building, back through your patio, back to your house, that's a fundamental issue. Then, yeah, that demonstrates, I think, a more basic issue. But if you put in a swell, but the swell wasn't designed perfectly, that's a minor issue compared to the drainage issue. Okay. The driveway. The park, oh. By that, yeah, by that I meant the calculations are probably off by at least 1 foot. Yes, it's not the slope. It's not the issue of the slope. You have a centerline slope at 2%. It's not low. I think it's mainly the calculation went wrong. I think it's off by 1 foot because you have 72.78, meaning that this is actually 72.28, right? And your 72.28 is so close to your 71.47. Which means, yeah, there's something yeah, could be. Yeah, I would base spot calculations on the nearest contour. Yeah, so it doesn't have a chain effect. It's not dependent on one thing. It depends on many kind of closest contours. Yeah, okay. Yes, this one is likely, this one is the one that is likely going to need a stairs to create a walkout. Yeah, the two in the middle are the ones that are easiest to create the walkouts. Occasionally, no, it could be one of them might need a set of stairs in order to get to a higher elevation to create a walkout, but it's not necessarily the case. Okay, yep. The spots, yes, yeah. I think you're missing one based on what we saw from Alexis. No, there are 4 over here, 4 over there, and then the other ones look okay to me. Yep. Okay. Yeah. All right. Cool. You're welcome. And next one is Amelia. Amelia, can you hear me okay? Just want to make sure that you can hear me okay. Okay, good. Let me pull up your drawing. Okay, so this is yours. Need more than 1 DI. Yes, we went through that. So you have a V-shaped contour. Did I share? Okay, let me share. So you have a V-shaped contour pattern, which is different from the W's that we have seen today. Your DIs will be in these locations. Basically, how you determine you need a DI is my water drains to the lowest area, which is this curve, right? Whenever it cannot go anywhere, which means there's a dead corner over there, then you need a DI. Those are the dead corners. So those are the locations that you would need DI in this case. Okay, so those are the DIs. Sidewalk and ramp. When creating my sidewalk, even though I kept the same width, it looks tilted to the side. Do you know? It's not that they look tilted to the side. I think it's probably this spot makes you feel that the length is a little different. That's probably the reason, but they look fine to me. The geometry of the sidewalk look fine to me. How do I go about creating a retaining wall? You'd have to work on your FFEs first, okay? Honestly, you probably need to work on your parking lot contours first. You have the centerline slope, but it doesn't look like the contour patterns are correct, okay? The quick way for me to double check, as I mentioned, is I project that to my driving aisle and I divide it into 4. And then I know that your contour should look like more like this. Then I mirror it, okay? So this is likely a contour pattern here. Without a correct contour pattern in the parking lot, you wouldn't be able to know what the spot elevations here is. And then that makes it difficult for you to determine your TFFE and BFFE. And the first thing that I would do today is to first fix my contours in the parking lot. The second thing, I would go back to the video the week before Thanksgiving, where we went through these, we went through how to determine TFFE and BFFEs in lengthy details, okay? That video is, we were in the main room, so that video should be right in your media gallery. Once we have that, you would have your TFFE, you would have your BFFE, then you can start talking about the retaining walls. I didn't see so far, I haven't seen an example from today that gives us a good fun basis for talking about. This one is, we went through a little bit of why you would need a wall that is going longer. And let's see. Probably, this example probably gives us some ways of reviewing the backside. Well, let's take a look at this one next once, and now try to stay in the conversation so that we can talk about retaining wall using Rebecca's example, okay? All right, so that is about the retaining wall. Yeah, I would get on immediately on the parking lot contours and those green spots where the contours, where the parking lot connects to your walkway. So these are, once I have my contours, those are the things that I work immediately on. And then I move to the spots that's right before I get on my patio, and then use that for determining or trying and picking numbers for trying my TFFE and BFFE. and see whether those sets of FFEs work. That's how I would proceed. Okay. All right, so I will go ahead and move forward with Rebecca's, and let's start with the retaining wall and back facial there. So Rebecca, I'm gonna quickly look at your spots here and see if they make sense. I will need the contour labels. Contour labels are very important for us to grade, so be sure to have those clearly labeled, even if, make that a priority. Otherwise, it's very hard. And you can see that I for grading, when I start grading for every assignment, I would need to do this first. So 69 and 68. Okay. So there could be, again, it's likely, let's see. I want to see if that one, yeah, it doesn't seem to me it's 4th. Yeah, Rebecca, there could be an issue with your, that looks to me closer to, well, neither looks to me it's connected to the quarter point. So you may, the first thing to do is to check your contour in the parking lot and see if their directions are correct. All right, if I were to just sketch it out and divide it in 4th, like that, close enough. Well, so maybe I'm wrong, but no, double check if you are connected to the right spot. It feels more like this. Anyway, so we have that and that. I do need some spots here in order to help me. If this is 69, yeah, if this is 69, then that being 70.40 is not, doesn't seem they are matching. Yeah, Rebecca, if you can unmute and help me understand the elevations here, that would be good. I turned up my volume here. Okay, probably should have made ask you to unmute.
So for the, I had a spot in the middle where you have that pink dot, and I used it from the top of the curb there to get to the 740 using the 2%.
Right. If the 69, no, if 69 is it's over here, that is about 68.6. And top of the curve, it would be 69.1. And I don't think you can get to 70.4 within that short distance. So there are some calculations that were off. Does that make sense? Unless this is 70 contour. But it doesn't seem like it's, unless we're missing a contour here that is 71. So this could be 71, for instance, then it makes more sense. And I need to know the contour number for sure. And so this is, if this is 70, then it makes more sense. Okay, I think that might be the case. Yes, that might be the case, because this is 69 and you have 68.950 here. Okay, if that's 70, then yeah, the set of number would be correct. Okay, all right. So if we have some the set of stairs over here, 64. Okay, let me scroll down. The 64, okay, you do not need a step out here. You could have it, but honestly, one step right out of your bottom floor and to your patio, it's likely going to be a tripping hazard. So imagine that you have a porch in your backyard. You would basically move very smoothly from indoor to outdoor without a step. So here you can have a 61.10 or 64.00, just have a tiny little difference so that water doesn't drain back into your house. And then you have that slope. So the spots here indicate that you have a walkout here. So in that case, you would also have, you know, the paving, the boundary of the pavement for your first unit. Now, if we move forward to this set, if this is 71, using 71.16 to get to 72.45, okay, 63. This one you need it to be sloped. All right, so the patio needs to have a 2% slope of its own. So basically, it will need to slope that way, slope this way, away from the building. And these can be the same, that can be the same, and these, yeah, that is a little lower, that's okay. That is a little lower, that's okay. Okay, so you can have these for now, but the BW is likely going to change once you have the sets of contours at the back of the houses figured out. And the length of the wall also is dependent on what the contours are in between of these two walls and how the contour connect back and forth all the way across. Okay, so these can be changed based on the 2% slope, and these two work, but those you will need you will need to wait until later, once you have your sets of contours, to adjust if necessary. Okay, so that's the backyard. Let's zoom out and see if there are additional questions. Swell lines look okay. Again, the swells, generally they look okay. It's better if you slope them away from your building like that. But very likely you won't need both swells, and the design of them would need to depend on your contours around those areas. The FFEs, if the current sets of, yeah, but this one is even more, it's even more obvious that the angle of the contours needs to be changed. 8, 9, that is 8.51, 69, and 64. So it looks like you're trying to create a walkout here as well. You probably don't need to. You already have the walkout here. So what I would say is you would not need a set of stairs here because you're not trying to create a walkout here. So the backyard, the back patio, those spots can be a lot higher than what you have now, making it easy to connect back to the 65, 5, 6, and 7 over here. So I don't think you would need a big set of steps in front of your last house. Okay. Let's keep this one because one set of stairs it's required. You do need to put inside your ramp somewhere here in the middle 2 units. Otherwise, your FFEs look okay to me, and they're 0.87 kind of in difference, which is great. So this one is not a 67.67. But I think you could adjust that with the change of the stairs. Okay, so you clearly demonstrated an understanding of the process. Some errors happened during the calculations, which would take you some time to correct, unfortunately. And that is also why we suggested working on your contours before you work on your parking lot spots. But I want to confirm with you that you demonstrated a good understanding of the material. There's still some work to be done, but hopefully you won't. Yeah, this is, yeah, I want to say this is not too distracting of your progress. I mean the contours in the parking lot. All right. The other thing, these contours need to be shaped that, in that direction. Okay. So those are correct. These one more is necessary. Walls are necessary, and that's likely going to attach to this wall, and we'll go from there for the other ones. And we're missing one in the turnaround. Does that make sense?
Yeah.
Okay.
How would I fix the distance of the contours like you were talking about, or the slope of them?
Okay. So if you remember, there's a 3-inch crown, which means that spot is 0.25 below that one. And what we essentially need to do is I need that line, that one contour spacing, I need to move it down, create a parallel line to the bottom to kind of align with the driving aisle edge. And I divide this line into 4th because I'm essentially looking for instance, for this one is 60, this is 70. I'm essentially looking for where 70 is. 70 is over here because this is 70.25. Does that make sense? So this is 70.25. So I'm looking for 70 along this line. And that is why I would just basically connect that one and mirror this one over. And for this one is the same thing. I would use the same line over here, divide it into 4th, and then that is my line. And I mirror that. So that is how those contours can be fixed. And then once that's done, you would recalculate that spot, this spot, that spot. Well, not exactly in the middle. It's actually the steepest side. The steepest side would be the lower side. Okay, let me erase that one. So you would use the steeper side to specify a 5%, or yes, 5%. That's the lower side, so it's the steeper side. Use that. If you want to use 5%, those are the spots that you base the 5% on. And then verify that these sets of, it's still achievable. Now you can adjust the walkway slope or adjust the number of steps. I would not use the steps over here again. Use the design of the walkway and steps to see if you are able to still keep the 72.64. All right, that might be possible because as you can see, your contour is actually moving in this direction. meaning that you're now higher. Actually, you're not higher than before, meaning that you can actually lower this slope to get to the same elevation of 72.64. Does that make sense?
Yeah, it does. Thank you.
Yeah, so you can actually keep the FFE here, just adjust that one. All right, the same thing here. You're actually being higher than before. All right. Okay, let me zoom back out and see if you have any additional questions there. Yeah, let's not worry about the stairs on the right. I think the representation by now, it still looks okay. Once you have more contours, it might be more cluttered, but you seem to have a handle on that issue. How do the contours work in the middle of the townhomes? It's very likely it's going to be parallel lines shaping uniform slope and sheet flows. So the 8 inches, okay, the 8 inches difference, what does that mean? It basically means this is one FFE, one set of BFFE or TFFEs, and that is another set. And the brick, think about the brick of the building, they need to line up. Okay, so the size of the bricks are in 8 inches increment, basically means if I have a lower building on the side, the difference can only be integer number of 8 inches. Does that make sense? So yeah, so if this is my next building, I do not want it to look like this. I want it to look like this. So that's what the 8 inches mean. We talked about the basement. Your DI, we talked about the DI with other folks' work. It's basically the dead corners, which are the ones that I just labeled. Okay, it will have a different one here. If you flip your contours, that's the lowest point. So those are your DIs in the roundabout. All right, okay. Anything else?
I think that's all. Thank you.
Okay, cool. Thank you. Okay. Let's see. Still, Layla. All right. I think this is yours. Okay. So we have the W. We have the contours. The W looks to me, the shape looks good. Okay, let me zoom in. For the bottom of the drive, we talked about that. You would not need a sidewalk over there because that's the lawn area. You know, people likely would not walk there without a specified destination. So we can only design, we could just design the sidewalk on this side. So that's that. Can I put my HPS? HPS will be somewhere here if you choose to have a swell. It's likely that you can end somewhere over here. The same thing, it's likely it can end, if you can design a shorter swell to get rid of the water, you choose to, I would say, shorter one will be better than a longer one because you won't be taking water away for a long distance, right? Okay, so that's that. Let's check the sets of the FFEs. You have 70, so this is around 70. And okay, this is a little high. Let's make it 5. And that should be 5. If you have, if this is what you get by using the set of FFEs, in this case, you add stairs. Yeah, you add stairs to reduce that one to below 5%, okay? So you have 71.19. Let's take a look at the whole picture and see if you have walkouts here, okay, walkouts here, okay. So it just looks like to me, you only need a set of stairs over here you can actually, again, not worry about having a high BFFE here. You can, this unit can be pretty low. This unit can be pretty low, and you don't, because you don't need walkouts, right? So you can have the backside be very high. Does that make sense? Because you don't need walkout. Mm. Mm. Yeah, I understand that logic. If you already have a walkout over here and there, you do not need a walkout there. It doesn't have to be at 63. Yes. Yes. Yeah. So you could lower this one to even 2% and let this drop. No, let this drop. That's totally fine. Because now your elevation here can be around 67 even. This doesn't need to be low. It could be 67. Yes. Yeah. Nope, they don't. So it's this situation, right? So that's the house. That's your first floor. This is your top FFE. That's your BFFE. If you don't have a walkout, the back can be this. Right? So it can actually be like that. And that spot is these spots. They can be below TFFE, but a lot above BFFE. Right? So you could even do something like, this is 67. What about if I do that? That's my 67. Right. Yeah. Yes. You don't have to do any math in that area. It's estimating. No, it doesn't. So you can see that that corner doesn't have a relationship, does not have to be a certain distance or certain difference from your BFFE. Right. I mean the corner, this one. Yes. Right. So if this is 70, 67, and let's just do a quick. If this is 70 and TC would be 70.5, 2%, suppose it's 25 feet, 0.5, it's going to be 71. That would be 71 something, and this is 62 and change, and totally works. Does that make sense? For that one, for this, where you don't need a walkout, you have a wall. Yeah. You can have that hit the wall. So if this is 67, I may move that actually up a little so that I create a little more room. Too big. That's my 67. My 66 can go. Ah, that's too dark. My 66 and go like this. I want to, no. Yeah, you kind of, no, this is 6 step 7. That's 7. Yeah, yeah, yeah. Well, what I drew here, it takes a long wall. I'm not saying this is the best solution. I'm just saying this works, okay? Now my 65, you're right. It has to attach to the wall. Because here I need to create 63 over there. That is 63, meaning that yes, I would have 4 contours that needs to hit the wall to make this work. I'm only saying this works, and I'm not saying this is a good solution again. So that needs to hit the wall, and then it works. I'm sorry. Then you would have a little, just a little swell just right here. Yes. Right. Now, how can I improve this? I make 60s, actually, I don't make 67 this low. I move this up and I let my 67 actually hit the wall here. Then I can save some walls. I don't need that such a long wall because I only have my 4 and 5 and 6 attached to that black wall there. '67 actually have to hit the wall here. It has to go in. There are 2 '67s. This is the one on the south, and that's the one in the north. They don't touch. Yeah. No, you hit the wall and go to the other side of the building. And then it's outside of the map that these 2 '67 eventually connect. Yeah. Yeah, the 66 and 67, they all need to hit the wall. Hit one of the walls. It could be the side of the building, it could be the one of the walls that you created. Off the page. The 66 would still go on this wall. It's on the other side. Yeah, 66 is on the other side. It hits the wall. It hits the wall here. 66 is over here. Original ones. It goes around. It goes around the building. There's 166 here. Yes. Yes. Right. Yes. Yeah, you can do that. Right. That's right. Okay. Cool.
So if you scroll up, my W, like at 69, I feel like it's wrong in my other shot.
This one looks okay to me. Oh, yeah. The calculation is off. Mm-hmm. Yeah, it looks to me that the calculation of 2%, now you can see that the distance here is not correct, right? That is supposed to be 0.25 of elevation difference. Now it looks like is the whole number contour, or 0.75 or 75% of a contour spacing. So I think it's probably misreading that spot. Yeah, that's probably going to cause some substantial changes here. Yeah, so this is actually 68.75. And 75 would be very close to a 69, right? Yeah, I think you probably need to move all these to the correct location. It's systematically move them over, and the high point would change. I think what you need to do is you would add 0.5 to every one of your spots along the sway. And I don't think is more than that, because by reading this as 68.25, you're 0.5 off. But if you add 0.5 to everything here, then that would match. But the thing that wouldn't match would be your original design of your back would not match, which is probably not a big issue. If you increase the 0.5 here, okay, you increase 0.5 here and 0.5, it doesn't really create much difficulty for you. Mm-hmm. You move your W and your V over half contour spacing. Your, yeah, yes, 0.5 contour spacing. I don't think on the right side, yes, on the right side, you would have a totally different slope though. Yeah, that's right. That's because your high point changed, so the other part of your center line slope changed. I agree. That's the bigger change, not for the left one. Okay. Yes. Yeah, you would only have that shape here. Once you move to the right location, it won't be here. And you do need to find out where 68.5 is along this line. So it goes like this out. Does that make sense? Yes, you trim it and once it hits the curve. That's right. Okay. Yeah, I'm afraid I will need to move forward because I have 2 more students, and yeah, well, you're welcome. Parker, you here? Parker, can you unmute to let me know that you are here? All right, cool. Okay, let's take a look. Draining inlets, we have talked about it. Hopefully we picked that up during the critique. Do draw a line perpendicular to the center line of the roadway to use the calculation of the spots. Perpendicular to the center line of the roadway. Well, there are definitely multiple ways of calculating your spots, but I would project a distance to the closest to contour and use that side slope to calculate. That's one way. And you could do this as well, do a parallel line, and then this spot will be the same as the one that you calculated for the corner. And if that makes life easier because of the 2% slope, I would do that too. So that's 2% slope, and the measuring that distance is likely easier for the calculation. So 2 ways, either way would be fine.
That's my question.
Yeah. Would turnaround be a risk? Okay. So the turnaround we talked about. Huh? Go ahead. Can you repeat?
What?
Will you? Yeah. Okay. were you asking a question?
No, I was not, sorry.
Okay, cool. So the turnaround would be looks like you would have another contour here. You would mirror this contour based on the line that you drew here, based on the distance that I know this one is a little closer, well, went over the circle. So you would have a tiny little bit of 70 or 69 contour there. And based on that, you would have DIs, that's the lower point, that's the folding line, that's a swell. Okay, you go down and you go up, right? That's the swell. So those are the locations of the DI that you would need there and there. So that's about the turnaround. Okay. Moving left. Well, that's the design choice. The way you designed it, you do need to create a spot elevation for every connection that you have. What I would do actually for more comfortable design in front of the patio, and the plus sign, why didn't it work? Okay, anyway, oh, it works, just too slow. Give me 1 second. When I get to my front porch, yeah, I guess my computer is also tired. All right, let me try to sketch it out as it loads. If I have a walkway like this, before it gets to my patio, like that, can you still see my pink lines? That's my porch. I would try to, yes, okay, thank you. I would try to turn, I would try to avoid a situation of a acute angle here. So I would try to create a landing of some sort like this. So before I get to my porch, I would already changed how I face my house in this area, and then I step up, or no, when it's without a step, I would have an area in front of the common or two separate porch to change my direction from facing that way to facing this way. Okay, I would not keep going like this and then face that way and then step up, because that acute angle is going to make it hard to make the area in front of the porch hard to use. That's my the suggestion for the design of the walkway. Okay, taking a look at the calculations here, 69. Yeah, let's move forward with calculating the TFFEs and BFFEs. I'm not sure, so that's the 72, that's okay. 1069. Yeah, because you don't have FFEs, it's hard for me to evaluate based on that. Parker, I'm not sure if you caught up with the previous views and are understanding the process of doing next steps. You can put in chat. Okay, cool. All right. Yeah, hopefully you can focus on the FFEs first. And so again, we would work on those spots and work on figuring out the FFEs and having a walk out here, walk out there, likely a set of stairs here, and do not worry about having stairs all walk out for this unit. And then next step, you would be moving forward with the front contours. Okay. And then the final step would actually be working on the contours in this area and come back and recheck some key elevations in the parking lot. All right. I'm glad you were following along during the previous reviews, and I know it's hard to be the last. Okay. Well, thank you for your attention. And I know I still have Lindsay that I need to talk to. Okay. Lindsay, I just want to make sure you're here.
Yep, I'm right here.
Cool. Let me go to your work. Let me clear everything and zoom in to see your questions. Do we need the spots? Our grading will stop somewhere, stop here. Let's see. We'll grade everything but on this box to the right, okay? These two and the transition, let's not worry about those. Do we need spots in the middle? You don't need this spot. You do not need that spot. And do need where it's slope changes and a fault. So those are necessary. And be sure to label your DI. I don't see your contour yet, so those may have not shown up. Because of that, it's hard for me to check if these numbers are correct. And the slope arrows are backwards. They need to slope that way. And based on that, I could safely say that you will need to recalculate these. That one seems correct. This one is going up. That one is going up. That one is, oh, sorry. It is actually all going up. It is all going up. So it's just the arrows are pointing to the wrong direction. So let's see. Based on that, how can I raise the FFE to make that? Well, if you already have a walkout for these two, you don't necessarily have to adjust that one. Okay. If you have to adjust one, you won't add a set of steps in front of the building to raise it up. So then you can have a walkout basement. But again, you don't necessarily have to. So definitely no walkout. This one, 62, 5, 3, 5, 4, 3, 2. Well, I would raise that one too. No, I would raise this one though, because you know the 62 is actually under the tree. Although you can drag this up and make it, I don't think that's a good solution. So let's raise this one in the middle. Raise FFE at least by 1. If you have 63.47, yeah, like it's much easier. And you basically just add a set of stairs in front to make that happen. The one on this unit 62, that one should work. 62 can be dragged up over here. Yeah, it should work for this one. So yes, walkout, no ADA, yes, ADA, and you can choose either one to put ADA access for this one or that one, because you don't have to have walkouts for either of these two houses. Does that make sense?
Yes, thank you.
Okay, good. how do you calculate the spots along these really lane wide curves? Do we use the length of the radius somehow? Do you mean the curve spots?
Yeah, so like along that like the middle curved piece, I use the length to calculate my spots, but I didn't know if we were supposed to use the radius instead.
In that case, you can actually project this to your center line and find out this one and minus 0.25. Does that make sense?
Yeah, thank you.
Okay, cool. Okay. So that's that. Take a look here. How do we form the contours? Oh, that's a good one. Well, without knowing the contours here, it's hard for me to very specifically talk about that. You have a 67.50. If you can draw your contours in this area, that would be helpful. So 71, 67 point. So there might be a 68 looking like this, right? There might be a 68 looking like that. In that case, you would have a 68 doing this. And we have to figure out, so we're going down and go up. We kind of have to figure out what the spot is here. If this is 68, that is 68, not 69 yet. Okay, so this is 68 and change, meaning that you would have a 68 contour somewhere. So you would have a closed 68, and then you would have another 68 that is wrapping around and then connect to this 68. And depending on how you treat the 68, that might be a 68 out of the roundabout. Does that make sense? So
Yeah.
yeah, if you draw a cross section, we're going down and then we're going up, and then we have a curve. And then we have a curve here. And then I basically need to figure out what the curve elevation to know the slope. So land is away from it. And then I go, okay.
I'm having a little bit of trouble hearing you.
Okay, let me turn off my speakerphone here. So this is, we're going down.
I'm still having trouble. It just sounds kind of muffled. I'm sorry.
Then I don't, yeah, I'm not sure what's happening. And try again, is it better?
Yeah, it sounds like it's better now.
Okay, so again, I'm drawing a cross section. We're going down in the roundabout and then go up, and then we have a curve. And outside of the curve, the land is sloping away. Now we know this spot is 69, is over 69, then, oh, over 68, sorry, because this is 68, and this is 68.3, for instance. So then top of the curve will be 68.7 or 8, like that. And then I know the first contour, no, on this slope will be 68. So then I need to, this one that I sketched out in pink will be 68. And then I need to look for where the existing contour is to try to connect it, right? And then outside of it, I would have 67 that needs to be connected to this one. Not doing a great job over there. And I know I will have 66 like this and 65, depending on whether this distance is reasonable. I will decide whether or not I need to move 65. Does that make sense?
Yeah, that makes sense.
Okay, great. So those are the questions that you listed there. Anything else?
If you just take a quick look at my spots, do they look like they're heading in the right direction?
honestly, I will have to look at the contours to be able to know for the parking lot.
Gotcha.
Yeah, without the contours in the parking lot, it's very hard for me to estimate. Yeah. These ones. Okay, so let me just comment on one of the sets of the spots. I'm afraid they don't work yet. So the spots, some of the spots are determined by the walkway. Other spots are actually determined by your land. Okay, so there are different spots here, which is complicated. Definitely, this is the most complicated part. We'll pick this location here. There are the spots on the porch, and there are the spots on the ground. They can be different things. I want to get rid of the yellow thing. Come on. Yes. Okay. Yeah. Good. So that spot and that spot needs to be marked on the walkway. It's always on the paved surface. And this and that and that and that, that is the FFE. That could be the same as the FFE, or could be 0.1 below the FFE. That's the front porch FFE. Okay, but this is the ground elevation. No, the porch can be above the ground. And in this case, it might needs to be above the ground. The reason being, and honestly, the ones on the ground needs to be determined by your contour. So I am estimating again, so your 70 is actually way here, which I'm not so convinced that is right. Yeah, again, I will need the contours. So, okay, so let's suppose your TC here is correct. Your 70 contour is actually going in this direction somewhere here, and we'll need to find out where your 70 is. If you don't have a 70 on this one, basically means your 70s hit the wall somewhere here. Okay, that's fine. So based on, let's assume your walkway calculations are all correct, meaning that your 70 contour, this is around where 70 climbs up the, not climbs up, but connects on top of the curb, right? Your top of the curb is around 70 over here, meaning that your 70 is starting here on the ground. And then this one is not correct. I know this is based on 0.5 below, but now it needs to be based on the contours. And this 70, if it go, okay, we'll need to calculate again. Okay, we'll need to calculate spots along this walkway to know where exactly 70 hits your walkway here first. If your 70 goes this way, it needs to be turned. As you remember that Stuart talked about, we can't have water draining to the sides of this wall. We need to elevate the ground elevation over here in order for water to drain out. Okay, so this spot, again, you can estimate for it to be a little bit higher than, well, if this is higher than 70, then your top FV doesn't work. Oh my gosh, okay. I now understand why you have that one. Yeah, sorry, take me a little bit to realize how I actually should change this to make it work. this is again a little difficult for me to critique because I can't do calculations to know exactly how the 70 actually goes on this walkway. And I am not exactly convinced that this is 70 here because we have 71, likely 71 over here. And I think this is probably a higher elevation. I don't know if that makes sense. But this 70 needing to go in this direction seems to me a little strange. I have a feeling that I'm confusing you.
I understand what you're saying, I think. Just that probably the spots on the bottom there aren't correct, which then kind of like moved everything else underneath it.
Yeah, I think there's something is off. Because the contour 70 doesn't seem to me should go as low as this one. 70 seems to me should be in this range. Or somewhere here, hitting the wall over here, something like that. Let's see. Let me take a look just to see if I might be completely. So that's, well, this is 8. No, that couldn't be 8. 8, 9, 10, 1. That seems more likely. Okay. So feels like this is more reasonable. And then if we do something like this, yeah, you can see that this is probably 71 and that's 70, that's 69, and that is 68. So again, I'm estimating, but I feel this is close to, no, even I can move this over a little bit. This is close to what is the contour shape. If that's the case, you're actually at 71.5 here above the curve. And your 71 contour is actually somewhere here. So there is some calculations that are probably off. That is creating a low FFE somewhere here. The 69 going down, go up, and then needs to go up. Yeah, I think that the elevations overall are lower than the actual ones. So a good step, yeah, a good step would be, let's verify the contours in the parking lot and then verify, at least starting with one set, for instance, this one that is pretty complicated. Verify these spots are actually correct and then go from there. But again, I'm pretty confident that you know the material pretty well. There are some mistakes, but hopefully it won't take too long to fix.
Okay, so moving forward, you think that I should kind of like wipe the slate clean, start with my contours, focus on how those are gonna connect,
Yes.
and then focus a little bit more on my spots and where I should be placing my FFEs?
Yeah, let's work on the contours definitely as the first step.
Okay.
And then choose one set. Choose one set to